All right, welcome to Chapter 10, Section 5, called Angles of Elevation and Depression. This one is for Integrated Math 2 or IM2. So just go over a couple of the features here on the main screen before we get started. The first thing you should see is a due date. I don't see that on my teacher preview, but you will see it on your student screen. Attempts is always unlimited, so that's true for homework, tests, and quizzes. Number of questions just tells you how many are in this particular assignment. Grading policy is always best score, so whichever attempt is the best one is the one you get to keep. And partial credit is enabled, so if you answer one or two questions correctly, you get credit for one question. I also believe it's partial credit within the question if there's multiple answers within the question. So down here it says, please remember once you start your homework, you must finish it before you can work on anything else. And that means once I click start, down here in the bottom right corner, you will see a submit assignment button. That's how we finish our assignment, is by clicking that button. And what it means by you can't work on anything else is the system is literally going to lock all of your other assignments and even resources until you click that submit assignment button, because it's assuming you want to leave this attempt open, and that's what it's trying to do for you. Remember, you have unlimited attempts, so you don't need to leave the attempt open. As long as you've clicked check down here, once you've done a problem, and then you've got a little green check mark, it will save your place or your progress. So you don't have to worry about that. You can come back and try again as many times as you would like, and it will keep updating your progress. So huge reason to click that submit assignment button so you don't get locked out of everything. The second big reason is that it actually affects the gradebook once you click submit assignment. So you want to make sure that you click that button so that you can see your progress in the gradebook and your teacher can see what you've been working on. Because until you click that button, your account's basically frozen. All right, let's look over here on the side. Sometimes we have a calculator. This is not always, but since we're getting into trigonometry, we're probably going to have the calculator quite a bit more often. Down here, though, we always have explanation, example, and message center. So explanation tells me I'm going to lose my current question attempt because it's going to give me the answer or solution to this question. So it's not going to give you the solution and then let you come type it in. Example will give you something very similar to what it is we're looking at. So you can see here's a little house, we have an angle measure, we have a length down here, and we have a question mark. So it's something similar to what we're doing here. And when they don't give us a little picture, I always like to draw one just so I can visualize what it is the story's telling me. And we're going to go through, and I'm going to go through and review the trigonometric functions real quick too, just so that we can remember those, because we learned about those last week. So once you go through and you're happy with the explanation, you know kind of what to do here, you can close this. You can open another example if you'd like to see another one. It'll be a brand new one. Or you can message your teacher directly from the screen so we know where to come help you, because it'll attach a picture of this problem. All right, let's go ahead and get started here. So like I said, we're going to review the trigonometric functions. So the little saying that goes with it, just to help you remember, and I know I put this on top of all the notes pages when we did this. We did it for a couple weeks in a row. I kept making you guys write this down again because it's just a helpful way to remember. So it's ka, oops, H, not A, ka, that's supposed to be an A, toa, so ka, toa, as long as you're spelling ka right. I don't know why I did koa, or I don't know what I spelled there the first time. So ka, toa. So this means sine, opposite, hypotenuse. So it's just a way for us to remember that sine of an angle, and this is just the symbol for theta for the angle, equals the hypotenuse, the opposite, over the hypotenuse, like that. So this is the first trigonometric ratio. Here, this means cosine and adjacent and hypotenuse. So cosine of an angle equals adjacent over hypotenuse. And then we have tangent, opposite, and adjacent. So again, it just helps us remember what's the name of the ratio we're looking at, and then what are the two pieces of the triangle we're looking at. So tangent of an angle equals opposite over adjacent. That's a really ugly, oh, that's a D. It just ran into my A. That's why it looks really funky. So it's just a simple way to remember. If you can remember SOHCAHTOA, I know it sounds funny, but it's a very easy way to remember that the trigonometric ratios, if you don't have them written down. You can always use your notes. So definitely, when you're doing tests or quizzes, even the final, we tend to let you have, the notes that you need to have. So if you don't have it memorized, that's okay, but, the more that we can remember off the top of our heads, the easier this gets. So with these trigonomic ratios, we do need to remember, what does opposite, hypotenuse, and adjacent mean? When I have a right triangle, which for this section, I'm going to have some kind of right triangle. We'll get to the pieces when we don't have a right triangle. But for right now, to use one of these three pieces, or even their converses, I need to have a right triangle in order to do this. So if I have A, B, C, then usually we just label them, A, B, C. The sides opposite are lowercase. This is A, this is B, lowercase b, and this is lowercase c, like that. So we usually have capital A's for the angles and lowercase letters for the sides. It's just kind of a way of labeling it. And the main thing when we're talking about opposite, hypotenuse, and adjacent, what we need to do is basically pick one of these two angles. You do not pick the 90-degree angle. That's never the one we're looking at. We know this one's 90 degrees. We don't choose this one. We either have angle B or angle A, one of these two. So if I look at this one here, the opposite is going to be completely opposite like this. So this is opposite. And then let's see, if I go red, the adjacent is actually the other angle that creates the right angle here. So opposite and adjacent create this right angle. So this one is considered adjacent right now because it's this other side here that creates the 90. And then we have the hypotenuse, which is always, always, always across from the 90 degrees here. So it's going to be this one. So this is the hypotenuse. Now, if I look at this exact same triangle, and I'm not going to draw it super nicely, but, close enough. I have A, B, C, and then A is down here, B is over here, and then lowercase c. And this is my 90 still. Well, now I'm going to look at this angle up here. So if I switch it, now I'm not looking at the angle down at the bottom, I'm looking at the angle at the top. Well, now my opposite is this bottom one because I did an A. Opposite. So now I'm looking at this piece as the opposite. And the adjacent is now this piece that was the opposite on the other angle. So you have to make sure you're paying attention to which angle it is you're looking at. It's not always going to be opposite on the side and adjacent on the bottom. It completely depends on which angle you're looking at. Hypotenuse doesn't move. This one is still across from the 90 here. So either angle I look at, this is still the hypotenuse. Doesn't matter on that one. That one doesn't change. Always, always, always across from that 90. Okay. All right. So now that we've, reviewed a whole bunch of that, let's go ahead and take a look at this problem. So a kite flying in the air has a 92-foot string. So we can see here's a 92-foot string attached to it. And the string is pulled taut, meaning that it's tight. There's no wave in it. The angle and the elevation of the kite, the angle of elevation of the kite, is 49 degrees. Find the height of the kite and round your answer to the nearest tenth. All right, so if we're talking about angle of elevation, and I'm going to draw another little triangle here just to kind of look at this. So if I'm looking at, say, the sun. Here's the sun, which we, don't look at the sun, but if I'm looking at the sun, this is kind of an easy way for me to talk about angle of elevation. Here's the ground from the sun, and the sun has risen up above, right? So this is an angle of elevation. It's elevating itself. It's going up, right? If I'm thinking of a line parallel to the ground, like this, the angle of depression would be going down. Depression is down. If I depress something, it goes down. Elevation means to lift up. So that's all they're talking about with angle of elevation and angle of depression. So this is the angle of elevation. It's going up. If I had a line up here going across the top that was parallel to the bottom, that would be an angle of depression. And they're actually going to be the same. If we think about the rules for parallel lines, then parallel lines and transversals, then we know that alternate interior angles are congruent, and that's what those two would be. They'd be alternate interior angles. Ooh, that is a giant eraser. What is going on there? Sorry, let me bring that down a little bit. I just wanted to get rid of my little drawing here so I had room to write our problem. Okay, so now that I've reviewed what does angle of depression and angle of elevation mean, because that, changes things a little bit. Now we're just taking a look at this and saying, okay, well, which trigonomic function can I actually apply here? I have a right angle, so I know I can apply one of them as long as I have two pieces of the three. So I either need an angle and one side, or I need two sides to find an angle. I can actually go back and forth with it, but I need at least two of the missing pieces, because this angle is a missing piece and so are the sides. So I have the angle, and this question mark is opposite, right? That's the height from the ground. So this is the opposite, and then this is across from the 90 degrees, which we call that the hypotenuse. So I want opposite and hypotenuse. Well, opposite and hypotenuse would be sine. So I'm going to take the sine of 49 degrees. I don't do that little theta symbol anymore. I know it's 49 degrees. Equals opposite, which I can do an O, or you can even do the question mark if you want. You can do H for height. Really doesn't matter what your variable is as long as it's a placeholder, over 92, because that's the hypotenuse. So now I can start to work this out. So if we grab our calculator here, I can go sine of 49 degrees. So I put it in here like that. And then in order to move this 92 out from under the fraction here, I would simply multiply 92 by both sides like this. Well, 92 divided by 92 is going to cancel out. And then I'm just going to know, okay, question mark is going to be equal to the sine of 49 times 92 degrees. And remember, the sine of 49 is the decimal or the fraction that I would get if I divided these two sides. It's equal to that ratio. So it just does that for me using this sign. It's a very common ratio that we use. There's even tables. There used to be tables in the backs of the books that actually helped us do this, but it's a little easier to use the calculator, I think, because it's a little more exact. All right, so I have times 92, and I get 69.433, and it keeps going, and it says round to the nearest tenth. So the 4 here, that's our tenth, right? So I would just need to make sure I look at everything past that and go, okay, well, this is not 5 or bigger, it's 3 or bigger, so I can just erase that. So I'm going to type in 69.4. So I know it was kind of a lot of review when we went through and did all this, but really you don't know which ratio you're going to use, so you need to have all of them at your disposal, like right there in your notes, so that you can reference and say, which one do I need to use? Which two sides am I referencing for the angle that they're asking me to look at? Because we could use any of the three. It just depends on the sides they give us. Okay, so we're going to do this guy again. So we have a 14-foot ladder, leans against the side of the house. The top of the ladder is 12 feet off the ground. So we can see that here. They're giving us a height this time. Find X, the angle of elevation of the ladder. Round your answer to the nearest tenth of a degree. So now we're missing the angle. And we can still do this. It's just we're kind of not going backwards. This is not the converse. These all do actually have kind of a converse to them. But what we're doing is we're going to find the ratio of 12 and 14, and then we're going to apply that using the calculator. So this one you would need a calculator. You kind of need a calculator either way, even for the last one. Or the table that usually is provided in the textbook. So just depends on what you have. But the table in the textbook will round it early because it only gives you 4 decimal places. It doesn't give you the whole calculator space there for the calculation. So Alex may not like that if you used a table instead of the calculator. Just a little warning there for the pickiness of the calculation. All right, so we have our angle is X. We're looking at opposite and hypotenuse again, because this is 12 is opposite, and this one's across from the 90 degrees, so this is the hypotenuse. So we're looking at sine again. So we have sine of angle X equals opposite, which is 12, over the hypotenuse, which is 14. So now I'm going to grab my calculator again, and I'm going to say 12 divided by 14. So this is the decimal. This is the sine of the angle. And in order to find out what the angle is, I need to do this little piece here so that I can actually go back to the angle. So if I have the angle measure, I use just sine. If I'm looking for the angle measure, I use this one here. So this is called the inverse. And as long as the whole thing is highlighted like that and I click it, it'll put it in the parentheses for me. So, just be aware of using your calculator that way. So if I hit equals, it'll tell me, oops, I didn't mean to hit it again. That was silly. 58.99728. So very long, and it says round to the nearest tenth of a degree. So if I look at tenth of a degree, that's 9. The one right after it is another 9, so this would round up to 59, and they're going to want me to put 0. I'm pretty sure they usually like to see that. I'll try it without the 0.0, but usually, yeah, round your answer to the nearest tenth of a degree, so they want to see that 0.0, that you've acknowledged that instruction. All right, so that was section 5, and I will see you in section 6.